I'm Anil Kumar sharing with you questions from my student Shruti. Shruti, thanks a lot for sharing these questions, and I hope the solution of these questions will help many of my viewers. While we are working on the topic polynomial equations, where the domain is complex numbers. The equation here is solve for x in each of the following, where x belongs to complex numbers. 4 questions are given. Now these are actually very good questions. First one is 5 times x plus 1 whole cube equals to minus 5. Then we have x square minus 5x minus 5 times x square minus 5x plus 3 equals to 9. Similar to this is x square plus 6x plus 6 times x square plus 6x plus 8 equals to 528. And here we have some fractions. X minus 1 over x whole square minus 77 over 12, x minus 1 over x, this is not a square, equals to minus 10. You can always pause the video, copy questions and answer them. Well, remember few things while you answer. Let me write 2 things here, which is kind of important to highlight. The number of solutions which we expect is same as is degree of the polynomial, right? So number of solutions equals to degree of polynomial. Second, we know that complex roots are always in conjugate pairs. Okay, so remember this while you solve, correct? So let's begin. We'll take up the very first question, which is 5 times x plus 1 whole cube equals to minus 5. X belongs to complex numbers. So let's bring all the terms to one side. So we have 5 times x plus 1 whole cube minus 5 becomes plus 5 equals to 0. You can factor 5 out, so get 5 factored. So we get x plus 1 whole cube plus 1 equals to 0. Now 5 cannot be 0, so inside term could be 0, correct? So we could now apply a cube plus b cube formula, right? So I hope you remember a cube plus b cube formula. It could be factored as a plus b times a square minus ab plus b square. So applying this formula here, we get 5 times x plus 1, that becomes a, right? So this is a for you. This term, the whole term here is a, and this is b for you. So when I say a plus b, it'd be x plus 1 plus 1. Right? That becomes the first term times a square means x plus 1 whole square minus ab means 1 times that, so minus x plus 1. B square means 1 square, so plus 1. Correct? So that's what you get. That should be equal to 0. Now we could expand and simplify this part. So we get 5 times x plus 2 times x plus 1 whole square is x square plus 2ab means 2x plus 1. Now open this bracket, which is minus x minus 1, and we have plus 1 here. So that gives you 5 times x plus 2. Combine like terms, we have x squared. 2x minus x is x, so we have plus x. Plus 1 minus 1 is 0, we are left with plus 1. So here we get one root, real root, which is x equals to minus 2 is one root. For the other root, we have to use quadratic formula, right? So now we have here x squared plus x plus 1. We'll use the quadratic formula to find the value of x. x equals to minus b, which is minus 1, plus minus square root of b square 1 minus 4ac over twice a 2. So that gives you minus 1 plus minus square root of 1 minus 4 is minus 3 over 2. So that gives you minus 1 plus minus square root of minus is I square root 3. So you know I is equal to square root of minus 1. Is it okay? Complex conjugate plus minus 2 roots divided by 2. So these are the 2 roots. So now we get our answer. So our solution is x is equals to minus 2, and it is also equals to minus 1 plus minus I square root 3 over 2, right? So we have cubic equations and 3 roots, right? So that is how it should be done. So I hope the steps are absolutely clear. Now let's move on to the next example. We need to solve for x. The equation is x squared minus 5x minus 5 times x squared minus 5x plus 3 equals to 9, where x belongs to complex numbers. Now as you can see here, we can make a substitution that x squared minus 5x is equal to, let us say, p, right? So what do you get? Now the equation could now be written as p minus 5 times p plus 3 equals to 9. I can bring 9 this side, minus 9 equals to 0. Is it okay? So what I did was that instead of x squared minus 5x, I wrote p. So we get p minus 5, p plus 3, brought 9 to this side, minus 9 equals to 0. Perfect. Now we are going to expand. So we get p squared plus 3p minus 5p minus 15 minus 9 equals to 0. That gives you p squared minus 2p and minus 9 and minus this is minus 24 equals to 0. We can use sum and product, 6 times 4. So it becomes p minus 6 times p plus 4 equals to 0. So we have p as equals to 6 or p as equals to minus 4. Is it okay? Now clearly you know p is x squared minus 5x. So substituting these values here, what do we get? So let's substitute p as 6. We get one equation as x squared minus 5x equals to 6, and the other equation is x squared minus 5x equals to minus 4. Correct? So these are the two equations which we get now to solve. So bringing the terms together, we get here x squared minus 5x minus 6 equals to 0. The other equation is x squared minus 5x plus 4 equals to 0. Correct? So now we are going to solve these two equations to find solution in the domain of complex numbers. Is that clear? So let's begin by writing these equations one by one. So we have x squared minus 5x minus 6 equals to 0. 3 times 2. So 3 times 2 is minus 6. If I add it, we have to have one positive, one negative. So we could have 6 and 1, right? So 6 and 1 can work. So we can write this as x minus 6 times x plus 1 equals to 0. So we get two answers here. One is x equals to 6. The other one is x equals to minus 1. Is it okay? So this is from the first equation, these two solutions. Now we are going to solve the second one, which is x squared minus 5x plus 4 equals to 0. 4 times 1, both negative. X minus 4 times x minus 1 equals to 0. That means x equals to 4 and x equals to 1 is another set of solution. So as you can see, we have a quartic equation and we have 4 solutions. So now we can write down our answer. and that is x is equals to -1, +1, 4, and 6, correct? So that is how it can be solved. So I hope the steps are clear. So whenever you have a situation like this, it is kind of better to do a substitution and solve rather than expanding and working with the polynomials of degree 4. That is going to be very difficult, okay? So as a practice, we have a very similar question coming up. Now here is another very interesting question on polynomial equations with complex roots. We need to solve for x squared plus 6x plus 6 times x squared plus 6x plus 8 equals to 528, where x belongs to complex numbers. So we can again write x squared plus 6x, which is a common thing here, as some other letter, let's say p, and then solve the question. We could rewrite the polynomial now in terms of p plus 6 times p plus 8. Let's bring 528 to the left side. So we get minus 528 equals to 0. Expand. We get p squared plus 8p plus 6p plus 48 minus 528 equals to 0. Combine the like terms. We get p squared plus 8 plus 6 is 14. And here we get minus 0 and 8, 480 equals to 0. We could factor this. To factor big numbers, my suggestion is to use factoring tree. So 480 could be written as 48 times 10, for example. And that could be written as, let us say, you could divide by 2. So 2 times 24. 24 could be written as 4 times 6, for example, right? And 10, you could write this as 5 times 2. So these are some factors which we can work with. You see, 5 times 6 is 30. And remaining is 16. So that gives a good combination, 30 and 16, correct? We'll give you 14 as your sum, and product, of course, will always be 480 since these are the factors. So we could write this as a combination of 16 and 30. So at 30, we need a positive number here, so 30 will be positive and 16 will be negative. So that's the equation. So from here you get two solutions. One is p equals to minus 30 and the other is p equals to 16. We had done a substitution here, that is to say we wrote x squared plus 6x as equals to p. Now writing it back, we get two different equations to work with. So now our equations are x squared plus 6p equals to minus 30, which could be written as x squared plus 6p plus 30 equals to 0. And here we have x squared plus 6p equals to 16. Since p is 16, I mean 6x, I'm sorry. I'm writing p again, 6x, sorry. So that gives you x squared plus 6x minus 16 equals to 0. And this equation, let me rewrite this. X squared plus 6x plus 30 equals to 0. So we get two quadratic equations now to solve. So we expect 4 answers as the case was. Now to get 30, 15 times 2, that doesn't work. So we may have to use a quadratic formula. 6 times 5, that doesn't work. To get 16, we could do 8 times 2. That works, right? So we could factor this one. It could be written as x plus 8 times x minus 2 equals to 0. So we do have two answers, which are x equals to minus 8 and x equals to 2 from the second one. But from the first one, it seems to be complex root, so we'll calculate. So we'll work with the equation now. X squared plus 6x plus 30 equals to 0. And we use the quadratic formula and find the answer. So x should be equal to minus b, which is minus 6, plus minus square root of b square, which is 36, minus 4 times ac. 4 times 30 is 120. Divided by 2a, which is 2. So that gives you minus 6 plus minus. Let's reuse the calculator. So we have to do square root of 120 minus 36, and that is 2 square root 21. I, because it is negative, right? So 2 square root 21. It's a negative number, so I've taken I here, divide by 2. And that gives you, dividing by 2 as minus 3 plus minus 2 cancels, I square root 21, correct? So we have 4 answers. These are for the first equations. We can add answers as x equals to 2 minus 8 and minus 3 plus minus iota square root 21. So these are the 4 solutions for the given polynomial equation. So I hope the steps are absolutely clear. You could use quadratic formula here also to factor anyway, but factoring tree as shown here helps you to factor faster. So we may have real or complex roots, but number of roots should always be equal to the degree of the polynomial when the domain is complex numbers, right? So we get 4 different roots as shown here. Let's move on to the last question now. So here is the last question of our series on solving polynomial equations, questions given by my student. Now let us see how to solve this one. It involves a lot of fractions. My suggestion is bring them together and then use quadratic formula. So we have x times x minus 1 over x whole square. Well, this square is not there. Minus 77 over 12 times x minus 1 over x. Bring 10 to this side, becomes plus 10 equals to 0. Now we can apply the quadratic formula, which is x equals to minus b plus minus square root of b square minus 4ac divided by 2a, right, directly. Where x for us is the whole thing, x minus 1 over x. You get an idea, right? So the whole thing. So what we get here is that x minus 1 over x is equal to, b is minus 77 over 12. So we could write this as 77 over 12 plus minus square root of square of 77 over 12. Okay. Negative also becomes positive. Minus 4 times AC means minus 40 square root divided by 2 times A is 1 divided by 2. So that's what you get. So let's use our calculator to figure this out. We have 77 over 12 plus minus. We'll calculate this value, which is within square root bracket minus 77 divided by 12 bracket close square minus 40, and this is equal to 13 over 12, right? So this square root thing, so this square root thing is 13 over 12, so we get 13 over 12 and everything is divided by 2. That's what you get. Is it okay? So we can now write this as, there are 2 possible answers, 77 plus 13, so which is 77 plus 13 is equal to 90, right? So we have 90 over 12 divided by 2 is 24, that is 1. Or we have 77 minus 13, minus 13, which is 64. Or we have 64 over 24, right? You would always simplify them, right? So 90 over 24 could be divided by 6, for example. So that gives you, this gives you, if you divide by 6, you could cancel this. Let me write like this. 6. 6 times 4 is 24. 6 times 1, 6. So 15 over 4. Here we could divide by 8, right? So 8 times 8 is 64. 8 times 3 is 12. So we do get two solutions. One is 15 over, this is equals to 15 over 4. And this is equals to 8 over 3, correct? So let me rewrite our solutions. What do we get here? So we can write that x minus 1 over x is equal to 15 over 4. This is one solution. The other one is x minus 1 over x is equals to 8 over 3. So these are the two solutions for us. So now we can actually solve these equations separately. Multiplying each term by 4x, we get 4x squared minus 4 equals to 15x. Bringing them together, 4x squared minus 15x minus 4 equals to 0. Now 4 times 4 is 16 minus 16, so it could be factored. So we can write this as 4x squared minus 16x plus x minus 4 equals to 0. You can take 4x common, so you get x minus 4. And here you can take 1 common, x minus 4 equals to 0. So x minus 4 is common, and you have 4x plus 1 equals to 0. And that gives you two solutions. One is, let me push this a bit, x equals to 4, and the other one is x equals to minus 1 over 4, correct? So we get these two solutions from the first equation. Now let's solve the second one. Multiplying by 3x, we get 3x squared minus 3 equals to 8x. Bringing them together, let's change the ink. We have 3x squared minus 8x minus 3 equals to 0. 3 times 3 is 9 minus 9. So, okay, so we could write this as 3x squared minus 9x plus x minus 3 equals to 0. So 3x is common. We get x minus 3 plus x minus 3 equals to 0. Now x minus 3 is common, and we get 3x plus 1 equals to 0. So we have solution as x equals to 3 and x equals to minus 1 over 3. So we have four solutions here, and these are the four solutions. So we get x equals to 4 minus 1 over 4, and we have 3 and minus 1 over 3. Is it okay? So that is how you could actually solve this particular equation. It's very tricky, but using quadratic formula as we did, it kind of simplifies the solution. So I hope you understand how to solve such complex equations, polynomial equations with complex roots. Thanks for watching, and if you like and subscribe my videos, that'd be great.